Hello friends, welcome to my channel. In this video I will cover ISRO 2017 examination paper I will solve. Exam date was this is part 2 of this series. Question is, a solid rod of 12 mm diameter was tested for tensile strength with the gauge length of 50 mm, final length 80 mm, final diameter 4 mm, yield load equal to 1130 Newton. What is the nearest yield stress and percentage of reduction in area respectively? So, initial diameter is 12 mm, gauge length. So, initial length is 50 mm, final length is 80 mm, final diameter it's 4 mm, yield load or P equal to 1130 Newton. Nearest yield stress sigma y we have to calculate, and percentage of reduction, so del L percentage we have to calculate. So first sigma y we will calculate. Sigma y equal to P by area. So 1130 divided by pi by 4, 12 square, 12 into 12. 1130 divided by pi into 3 into 12. If you solve this one, you will get 10 megapascal. So from option B and D not possible. Then you have to calculate percentage of reduction. Reduction in area. So products. Here you have to calculate del A percentage. So percentage of reduction in area. Reduction of area equal to change in area divided by original area into 100, because in percentage we have to calculate. So pi by 4 it will cancel, pi by 4 di square minus pi by 4 df square divided by pi by 4 di square into 100. Pi by 4 you can cancel. Then here we will get di, its 12 square is 144 minus final diameter is 4 mm. So 4 square is 16 divided by di, it's 12 square 144 into 100. So 128 divided by 144 into 100. So A is not possible. C is the answer. It will come around 90%. When water at 0 degree Celsius is heated, its specific volume under standard atmosphere from 0 degree Celsius to 4 degree Celsius. First specific volume, it will decrease, then it will increase. So first decrease, then increase. B is the answer. A spherical joint has dash degree of freedom. This is the example of spherical joint. Here let these axes are x, y, and z axis. Linear axis, here linear movement del x is not possible. So here also del y not possible. This side also linear movement not possible, del z not possible. Only rotation movement is possible in this axis. Here also rotation possible. Here also here rotation possible. You can write them del phi or del theta, del phi and del psi. These three rotations are possible. So degree of freedom is 3. C is the answer. Here also if you check x, y, z, linear movement not possible, only rotation is possible. From 6 degree of freedom, 3 linear movements are restricted, so only 3 rotations possible. Degree of freedom is 3. Isometric projection of a sphere is, its answer is circle. Isometric projection is, it represents 3 dimensions of a solid in one view. It will show 3 dimensions in one view. If you draw the isometric projection of sphere, you will get circle. ABC inventory control focuses on those. ABC inventory control, its graph will come like this. Total value versus number of items. For A items, you will get value around 70% and number of items around 10%. Value is maximum and number is minimum. Here you will get in between 70% and number of items, it will come, total value you will get around 20% and number of items around 20%. Next, for C items you will get total value around 10% but number of items around 100%. So here A region, then B region, then C region. So its focus on A items, which consumes maximum total value and minimum number of items. So items which consumes more money, value is maximum 70% A item. How does the viscosity of fluids vary with increase in temperature? So whenever temperature increases, viscosity of gas will increase, and in case of liquid it will decrease. So from option, increases gas, decreases for liquid. C is the answer. It's required to connect two parallel shafts, the distance between whose axes is small and variable. They can be coupled by its Oldham coupling. Oldham coupling is third inversion of double slider crank mechanism. Already discussed. Double slider crank mechanism. Here fix is this connecting rod. You have to fix this connecting rod. 1 is frame, 2 is slider. Here 4 also slider, 3 is the connecting rod. Connecting rod is fixed here. 3 is fixed. You will get Oldham coupling. Under what condition does flow separation takes place? We know dP by dx is less than 0. This is favorable condition. Favorable condition, and flow is attached flow. Attached flow. Here dV by dy at y equal to 0, it's greater than 0. This is for favorable condition and attached flow. And dp by dx is greater than 0. This is flow is separated. Flow is separated. Adverse pressure gradient. Adverse pressure gradient. So from option flow separation, so this one here dB by dy at y equal to 0 is less than 0 for same condition. Flow is separated and adverse pressure gradient. So from options flow separation, so this one for flow separation, these two. So dp by dx is greater than 0. A is the answer. The variety of cast iron which has maximum hardness. Cast iron types are, first is grey cast iron, then here malleable cast iron, then ductile cast iron or iron, then white cast iron. Ductile iron also we can call SG cast iron or nodular cast iron. So here they asked for hardness. Hardness is in BHN, Brinell hardness number for grey cast iron, it's around 200 to 500, and for malleable cast iron it's around 130 BHN to 250 BHN, and for ductile cast iron it's around 170 to 270 BHN. And white cast iron, this is hardest. White cast iron specialty is whenever hardness is required, we use white cast iron. So this is hardest. It's very hard and brittle. Its BHN around 280 to 700 BHN, Brinell hardness number. So our answer is white cast iron. D is our answer. Kutstack criterion for determining the number of degree of freedom of a mechanism with L as number of links, J as number of lower pairs and H as number of higher pairs. We know our formula for degree of freedom equal to 3 into n minus 1 minus 2j1 minus j2. Here n is number of links. Here number of links is L, and number of lower pair, this one j1, its j, number of higher pairs is capital H. So in this question, in degree of freedom f is n, so n equal to 3 into capital L minus 1 minus 2 into j minus capital H. So from option 3 into L minus 1 minus 2j minus H. C is the answer. The crystal structure of cementite Fe3C, it's orthorhombic structure, and FCC is austenite. Austenite is FCC structure. This is very, very important. And ferrite and delta ferrite both are BCC structure. Alpha ferrite and delta ferrite both are BCC structure. Hardness will be highest after which of the following heat treatment process? So we know furnace cooling we are doing for annealing, air cooling it's for normalizing, then oil quenching and water quenching both we are using for hardening. Here hardness is highest in oil quenching and water quenching. This is the table for cooling rate. Cooling rate is maximum in brine and sodium hydroxide. After that water, then oil, least is steel air. So in this question, maximum hardness we will get in water quenching, then in oil quenching, then air cooling, then furnace cooling. So D is our answer. In which of the following type of gear train the first gear and last gear are coaxial? So first gear and last gear both are coaxial. We will arrange two gears like this. Then gear 1 and gear 2, gear 2 and gear 3 both are connected in same shaft. Then gear 3 and gear 4 and 1 both are coaxial. So this is the example of reverted gear train. 1, 2, 3, 4, 4 gears are there. First gear 1 and last gear 4 both are coaxial. Thank you friends. Thank you for watching my video. Thank you.